I'm going to take a look at slide 11 where it says practice makes perfect at the top, and we're going to look at three different equations. The first one that we see shows two mercury oxides decomposing or breaking down into two mercuries plus O2. And again, we don't see a coefficient in front of that O2, so we're going to make the assumption that it's a 1. The instructions say write all possible mole ratios for the following chemical equation. So exactly like in math, think about this. How many moles of mercury would be produced, or excuse me, for every mole of mercury oxide? So if this right here were our ratio, I have to look at the coefficient in front of the mercury oxide, which is a 2, and then look at the coefficient in front of the mercury, which is a 2. Well, again, think back to math. You would do the exact same thing in math. You would reduce this to 1 over 1. If I asked you for the ratio of mercury oxide to oxygen, again, look at the coefficient in front of the mercury oxide is a 2. Look at the coefficient in front of the oxygen is a 1. So that's my mole ratio for mercury to oxygen. The next equation that you see there on the slide is 4 moles of NH3 plus 6 moles of nitrogen monoxide produces 5 moles of nitrogen plus 6 moles of H2O or water. So same thing, that if I was trying to write as many of the mole ratios as I possibly could, let's just take a look at what's the ratio of NH3 to N2. So look at the coefficient in front of the NH3, that'd be a 4. Look at the coefficient in front of the N2, that would be a 5. And so for every 4 moles of NH3 that we have, 5 moles of nitrogen are produced. Let's take a look at another one. If we were to look at NH3 compared to H2O, we would have 4. Coefficient in front of H2O is a 6. Again, think of these like a fraction. This can definitely be reduced, and it would be reduced to 2 over 3, or 2 to 3. Another mole ratio, we could take a look here at nitrogen monoxide and compare it to just nitrogen. If we do that, look at the coefficient in front of the nitrogen monoxide is a 6. The coefficient in front of the nitrogen is a 5. And so hopefully at this point you kind of see that coming up with the mole ratio is not difficult. The next step in this is going to be looking at how does this apply to stoichiometry and when am I actually going to use this stuff. And that's what I'm going to talk about next.